And let me tell you a little bit about the Scaleout collaboration, but I'm going to hand over mainly to Victor. And so our thinking is what we need in the world of federated learning is a lot more interoperability so that we can see fast adoption. We can see bigger and better forms of federated systems being developed. And what we want to provide, particularly from Flower, is for our Flower users to have a wide variety of tools available to them. And so now, with this collaboration with Scaleout, we're going to allow people who are building against the Flower APIs, people who are building Flower clients, the ability to run these in the variety of Scaleout deployment vehicles and types of frameworks and so on that have been built by these great folks at Scaleout. And so we think this can lead to people building federated systems that could not be literally built before without this collaboration of Scaleout and Flower. So I'm going to turn over to Victor. He's going to tell us more about it, tell us more about Scaleout. We see this as the first step towards a broader collaboration, but this is an important step where we can see the initial client being able to be deployed, and then we can start to move forward from there. But Andreas is also here from Scaleout, and so I'll hand over to Victor so he can start to tell us all about it. He's going to show us a demo, and at the end we can have some discussion, also including Javier. So thank you, Victor, for joining us and being able to tell us more about this exciting step.
Thank you, Nick. Happy to be here. I'll take the screen. Okay, so my name is Viktor. I'm a machine learning engineer at Scaleout. I focus on privacy questions in FL, and I've also been working a lot with this collaboration between Scaleout and Flower. So I'm going to start off with a few slides here. I guess most of you know what Flower is. I'm going to tell you a little bit of what we are focusing on with the FEDn framework. So it's a framework similar to Flower. It's made for federated learning, but we are putting a large emphasis on truly distributed federated learning. So the goal of our app FEDn is to take projects from R&D to production. So we want to make this easy and want to make it scalable and robust. FEDn consists of two parts. We have the SDK, which is open source. This is where most of the FL code is, and this part is organized, and we're trying to make it secure and good. But you can check this out on our GitHub page. Also, we have our managed platform, which is not open source, but we want people to use it on-prem still. And this is designed for production. So you can host this entire setup with Kubernetes, and it consists of many different services and parts that is used to organize this FL thing. And how this is different, I guess, from the flow of FEDn differs from Flower is mainly two things, I guess. We have a REST API where we can get tokens or JWT tokens for clients to connect with, and we also allow for, or we have this reduce combine topology where combiners are used to aggregate, so we can allow horizontal scaling with this and have a lot of clients, I guess. And yeah, we're trying to do Scaleout plus Flower. I guess Scaleout and Flower talked, and we realized that this would be a great effort to unite the FL community and allow Flower users to use what Scaleout has to offer as well as what Flower has to offer. So I'm going to jump into a little demo of what we have done so far. We're done with the first step of this integration layers that we're trying to build. So what we can do now is we can run Flower client server apps inside of FEDn. And the next step is going to be to also run server apps in FN, but you will hear about that in the future. But this is the first step, how we can do it. We have a Flower client here and a client app. And here we can import this client app into our FEDn client, the entry point for the FEDn client. We have built an adapter for the client apps, which translates, or it calls the client app object and translates the results back from calls to the client app back using Flower code, and it goes back to generic results, which we can use in this entry point. So we have some code here in the adapter to just translate messages back and forth between what Flower uses and what FEDn uses. Now we can use this in our FEDn functions to just get the results from the Flower client. So we can train and validate and just send it back to the FEDn app. We also have this FEDn, I guess it depends on this environment file. It's going to be used by the FEDn backend. And if we add this Flower flag to FEDn, then it will add the Flower dependency as well to this. I'm going to show you how we can run this using Studio. So first step of running is to upload some things to Studio. So we'll start with building a model. So we'll initialize a model and build initial parameters. And then we're going to upload these initial parameters to Studio, which is the managed platform. To do this, we also need to install the dependencies, and this happens automatically here when we build. Maybe we can. So we have I have prepared a project here already. It's just to start a project. We can actually begin by getting this. So this is how you call the REST API and get a discovery token here. And we can just add this to a file here, client.yaml. We add this token, and this token is going to allow the client to connect to Studio. And now we have built the initial model parameters. We also need to package the client code. So we can distribute this client code out to different clients as well. And we run FEDn package create, give the path to where the client code is. And this just packages the client code. The next step is to upload this. So you can do this either through the UI here on the web page, or you can connect with an API client, which I'm also going to show you. But let's begin with just uploading here. So we upload a package, which is the code for the client. We also need to upload a model. And with that done, we can actually start our first client. So here we add this client.yaml file, which we have the token in. Start the client, and it's gonna install the dependencies and then run the client. Actually start, since we're on the same host here, so we're on one device, we can use the same token to connect with multiple clients. So we can add another client as well. Since the first client is on, we can start a session. We can just do 2 rounds here, I guess, to begin with. And you can see that this first client is the training. This one is still downloading its dependencies, but it's gonna join in on the next round. And here in the studio, we can see that we're gonna get models added here. So there's the first model, which is the aggregate from the one client. And can also see here, this is, I've swapped out models here a few times. So this is from earlier training, 14 rounds. And then just now we added a new client. So it's, or new parameters. It's back to 0 again. There you can follow the performance through multiple sessions that you can run. And yeah, that's 2 clients running. So can also show you how to use the API client to start sessions or fetch information from the studio. So to do this, we need to first add a access token. We need to add this to our environment variables with FEDn auth token. After that, we need the host. We can get from the dashboard here, we can get the host to the controller. And from any Python instance, we can do import the API client. And add the host. Need to set secure to true. And from here, we can also use this API client to get models. Get a bunch of information there where you can just fetch and read whatever you want. You can also use this API client to start sessions, for example. Oh. Start a session. And these clients are going to start again. So I guess that's what I had for on FEDn. So now this is the initial step. We can run client apps, and in the future, we want to run whole Flower project, so or Flower client apps and Flower server apps in FEDn. I think that's going to be very cool. So that's all. Thanks.
Yeah, well, thank you for that demo. It's great. I mean, people do a lot of talking, I think, in the world of machine learning, but it's important that people actually start to deliver on some of the discussions. And so there's been discussions about, the need for interoperability and the, allowing people to combine different tools, particularly in the world of federated learning, where the whole idea is to enable people to assemble what is normally disjoint and inaccessible. So it's kind of an obvious place that you need these sort of things. But so often people just talk about it and never make it happen. But we have had a great experience working with Scaleout, and you guys have made it happen working with us, and we have a live demo. So it's critical. Thank you.
Yeah, I agree.
Javier, do you have any, I don't know, reflections, comments about this?
Yeah, I mean, I think main reflection is that I'm quite excited to see that we managed to start this collaboration, and now you can run all your usual Flower clients inside the FEDn framework and take advantage of the dashboard that Viktor was showing us. But I have one question that maybe I missed understanding when we were working on the collaboration. When you are, for example, installing the clients, when they pull the dependencies and all that, where are these dependencies being installed? Are they in a new environment only for that particular client, or can you maybe describe a bit more how it works? I think would be also interesting for others.
Yeah, for sure. That's actually accurate. So it's a new environment that gets created just for that client, and then it gets deleted when the client is done, or when you stop the client. It's a new way that people are starting to do this kind of thing, I guess.
Okay, interesting. And regarding how to load the data, for example, that a client has to use, that is done, is there a FEDn component doing that, or is loaded at the same time you load the Flower client?
So in this code that we have here, the data, typically for FEDn, the data is decided by yourself, but with this adapter that we built and the entry point, we're using the Flower client ID. So that gets sent from through the adapter, and you need to inject the client ID to clients as well. But there's information on that in the example on GitHub. But we use Flower datasets and client IDs to distribute the data.
Okay. So load data, the function load data is using Flower datasets, you're saying?
Yeah.
Okay, cool.
Andreas, I see you raise your hand.
Yeah, no, sorry, I just
jump in.
Yeah, sorry, I just wanted to jump in and also answer I think this question about environments is interesting. This is a quite new feature in FEDn, and it's quite flexible. So the default is that you will pre-build the environment, but you can also then configure it so that you reuse it, or you can also skip the building of the environment and have a pre-built environment if you have a Docker image. So I think actually I don't know if either of you have used MLflow at all, but the way we do it is quite inspired by how they manage projects, to the point that we actually use some of the MLflow APIs for doing it.
Interesting, yeah. I've only used the most basic features of MLflow, so probably I didn't see that part.
Let's take a couple of questions. If anyone in the room wants to ask some questions, just raise your hand. I'll take a look on Slack to see what I can find. Here's an interesting question. It's saying that really love this idea of federated learning, new to the space, and they want to know what would be sort of your favorite FL application. So I guess directly to the Scaleout folks, maybe it could be something you've seen some users do, or something that inspires you, or something. But this person is sort of new to FL and is wondering what's your favorite kind of use case.
Do you want to take that, Andreas?
Well, I can say mine, and maybe if you have one, you can also add it to it. No, but I think that there are, of course, many cool things. I mean, on a personal note, I have a background in biotechnology, long going back. So, like one of the applications that FEDn is used for is Swedish hospitals training brain tumor segmentation models, and this is an application I guess we have seen in different international communities, and there's one in Sweden as well doing it. And I think this one, of course, is really nice because it's clearly like an area where progress in AI is going to be completely blocked by data sharing issues, at least in Sweden. So it's illegal to move data outside the hospital walls in the Swedish system. And so that one I really like actually, and that we managed to progress it to patient data. I think, yeah, but there's several cool ones as well. I really like the cross-device things as well from a researcher perspective. I'm also like a university professor, and initially, like I really like this kind of challenge of scaling to millions of devices. But if I had to pick one, I think it's this medical one that I think is feels very good.
Viktor, how about you?
For me, it's I worked a lot in the automotive industry, so that's the one for sure for me. I worked closely with Volvo here in Sweden, and I think one of the challenges they have is that like the data distribution is constantly shifting. So it's really difficult to have fresh data to train models for cars. But with FL, we can just use new incoming data and keep improving models. That's one I really like.
Cool. Let me see if there's anything else. Oh, this is interesting. I guess it's asking any kind of insights or reflections on designing a framework. So I guess there's lots of different sort of frameworks out there, but maybe in the construction of this one, you might have had an interesting design decision to make, or kind of a perspective on how it could be anything, I suppose. It seems like a very general question, but they're just wondering, given you've built this infrastructure up, you might want to comment on some interesting design decision or user experience decision or something in the process.
Absolutely. So maybe I can take that. You're quite new in Scaleout, Viktor. But yeah, so I think one of these kind of very early things that we did when we started, we decided from a design perspective that there shall be no open ports on the clients, which I think was very important. That's kind of critical to run it in a real world setting on a hospital, for example. So that was kind of like a big decision that essentially precluded a lot, or at least would make, for example, peer-to-peer systems very hard. So like opting for like a more traditional server client architecture that was kind of steering in that direction. But then for us as well, we made this early choice to make these, we call them combiners, like they are aggregation servers in the FEDn framework, to make them as stateless as possible. So we wanted to have a tiered architecture. And that's what we realize now. But I think also like moving forward, like going for this kind of hierarchical approach to federated learning, we think is quite interesting and has a lot of potential in cross-device learning. So currently we have like a tiered architecture where you can scale, you can have an arbitrary number of aggregation servers that can be geographically distributed. There was also like a design choice that of course added quite a bit of complexity early on. Sometimes I joked like with the team that we have, our far scalability is ahead of federated learning maturity. But in the same time, it was also like a very interesting thing to work on. I think those two were quite early decisions that I think had a lot of influence on our development. I would say, yeah.
It's really interesting. It makes me think of perhaps one of the things we can explore together would be to look at building some sort of hierarchical FL system where we could use this interoperability. Given that there seems to be an over sort of attention to these very flat topologies, whereas you can really kind of think and see some of the value from FL of stitching together relatively large separate FL systems. Maybe for this hospital scenario you mentioned earlier, it could be a whole Swedish infrastructure, and maybe the UK. We could finally have a bit of
exactly. That's a very good point, because it also adds another level of security that you can you have like a local aggregation going on. I think that's very good. We should look into that, I think.
Yeah, it's funny that people they really haven't looked into that much. There's so many papers that look at this very flat, but I mean there'll be other additional issues to explore once you have these systems. I'm sorry I interrupted you though.
No, I just a general comment as well on what you said in the introduction there about interoperability. I think you and I both have academic backgrounds, and I'm sure you have also seen in past work like how premature standardization in mature R&D fields can actually be quite harmful. There's advantages, but there's also a lot of potential harm in driving research towards a certain state or a certain. I saw this a lot when I worked previously in systems biology, for example. It helps, but it also limits the way people think or the way new algorithms get formed. So I think I'm really happy about this collaboration. I think this is like a good sort of level to facilitate for the user, to try to reduce fragmentation in the landscape without sort of premature standardization. I think that's really good.
No, I agree. I think it's still we're still very early in this situation, and so we might not even know some of the main problems that we'll encounter until we start to really build and see some of these things happen. So well, thank you so much. It's a great collaboration. We're going to keep on pushing forward. We're going to make this the compatibility more seamless and kind of give users great choices to build the systems they want to build. So thank you so much.
Thank you.
Thank you.
Thank you, Viktor.
Thank you.